Efficient warehouse management is not an easy endeavor. Moving goods from one location to another is a repetitive, time and effort-consuming task. Using a robot fleet to perform these tasks improves the efficiency of warehouse operations. The robots relieve the operators to do a great amount of heavy work. However, internal robotic tasks, such as locating, or navigating in a safe way, requires a great amount of the computational resources. This constraint doesn't allow us to use more advanced technologies inside the robots. Dcenter empowers the robot fleet with advanced technologies that could not be applied before in this use case. This demonstration will show the capabilities of Dcenter applied to robotic logistics in warehouse environments, integrating artificial intelligence, and showing the power of containerization applied to a robot fleet. Traditionally, the robots run its software directly over the operating system, that is called bare metal. That brings some problems. Each robot is factory set up with a specific set of software versions. With time, an update will be needed. If an update introduces a bug in the system, there is no easy way to roll back to the previous state due to dependency problems. Dcenter brought the cloud-native technology of containerization to the robot and edge devices. Now we can have each software part in a separate microservice with all requirements encapsulated. That allows us to switch versions forward and backward without the dependencies problem. Additionally, by using this structure we will be able to outsource some of the software to less loaded devices. We will present 4 different scenarios. 1 before applying Dcenter, and 3 after applying it. The actors will be an edge device that will contain the fleet management system and AI. 1 Robotics RB1 base, that will act as the main robot. Another Robotics RB1 base, as a secondary robot. A human worker. A pile of boxes as an unknown obstacle. The RB1 base are equipped with a laser rangefinder that will allow the robot to detect nearby objects and stop in a safe distance. A RGBD camera that will allow to take photographs of the objects found in its front. Lights and buzzers to alert humans of its presence. A high-speed wireless interface to communicate with the fleet manager and other robots. All 4 scenarios will share the following. The robot will be asked by the fleet management system to go to a specific location. The shortest path to the goal will be blocked by different objects. The Dcenter components used on this demonstration are infrastructure management, cross-border data management, and AI package. In the before Dcenter scenario, the path will be blocked by a pile of boxes. When the laser rangefinder detects the obstacle, the robot is unable to recognize what kind of object it is facing. So it will assume the worst case, considering that it has a human worker in front, even if they are boxes. For safety reasons the robot will stop, and wait until the path is free again. In this case, if a secondary robot is routed to this path, the situation gets worse. The secondary unit will be double blocked by the main robot and the boxes, leaving both missions unaccomplished. Now we will use Dcenter in the same scenario. When the laser detects the obstacle, the robot will stop and take a picture. Using this image, the AI microservice will be able to identify the object in front of the robot. This pile of boxes will be identified as an unknown obstacle. So, the fleet management system will block this path and reroute the robot. In scenario 2, Dcenter will be applied, when a human worker will be on the path to the goal. In this case, the obstacle in front of the robot will be identified as a person through the captured image. Now, the fleet management system will ask the robot to alert its presence to the worker in order to clear the way. And when it is done, it will continue to the goal. At last, another RB1 base will block the way, and the object recognition will identify the obstacle as a robot. With this information, the fleet management system will only reroute the robot, leaving the path available for future actions. The following key points of innovation that Dcenter contribute are: detecting a human or robot by camera with a confidence greater than 70%. Detecting the position of the human or robot by the laser scan within less than 500 mm. Reduce the computation saturation of the robot CPU by 10%. Replanning robot's mission based on the information provided by the AI. We are going to highlight the benefits of Dcenter by comparing the robotic logistics use case before and after applying it. Before, the robot software ran on bare metal. Now, the software runs in containers. That brings a more homogeneous deployments and the ability to update over the air or perform a rollback easily. Before, the robot could only run its own processors. Now, these processors can be placed over the idle robots or even into the edge device. That reduces the use of computational resources and allows the robot to achieve longer runtime periods without recharging the battery. Before, if an AI was wanted to be used, it must have been implemented and trained by the robotic provider. Now, AI packages and models are available from a repository, which allows us to use different training sets or recognition algorithms effortlessly. Before, when a robot finds something blocking in its way, it wasn't able to recognize the type of object it was. The only possible action was to wait until the path became free again. Now, using AI, it's capable of distinguishing among an unknown obstacle, a person or another robot. With this information, the Fleet Manager system makes a smart decision in each case, including rerouting to an alternative path, alerting a human to move away, or blocking this path to other robots. All these features improve notably the warehouse efficiency. Thanks for watching. For more information, visit the Dcenter project website, www.dcenter-project.eu.